I'm going to try and hook up this motor controller to this little chassis here. The motor controller is kind of neat. It can control two motors. And so let's try and move these first two. I think I can mount this right here. These two outer terminals here are for the motors. And it doesn't really matter which direction you put them in. Ideally, it should be consistent, I guess. But that's our two motors. And then we've got to bring in some voltage. This thing is kind of cool, actually, because it's got a little 7805 in it, which is a voltage regulator. So I can bring in up to 12 volts on here, and it will give me 5 volts back out. That's ground in the middle. So this is actually a nice little, if you need 5 volts, it's a great little place to get it. If you can run it above 12 volts, because the power that goes in here goes to the motors, but you can run it above 12 volts, but from what you read online, it doesn't work all that great. So we're not going to go above 12 volts anyway. We're going to run at 5 volts. These only require 6 volts, so we're okay. So we'll hook up power in here, and then we'll hook up the speaker, or the two motors, and then I'll explain these little pins here afterwards. So let's do that. So now we've got these, so this is power and motors hooked up. Now we've got these pins, and for each, there's 6 pins here total, and there's 3 for this motor and 3 for this motor. And there's an enable pin, which is your pulse width modulation, which is how we're going to start and stop the motor, like a square wave. And then we've got 2 enable lines. So it looks like this. Pulse, let me turn this so you can see it. This is pulse width modulation on 1 pin, enable 1 and enable 2. So basically, if we bring this to a high and then low and high, it will go clockwise or counterclockwise, whichever. Goes in a direction. If it's high and we go high and low, it goes in the other direction. If it's high and whatever they are equal, so if they're both low, low, or high, high, then that's a hard stop, which means there's actually current going to the motors, but it stops right away. And if it's low, then it doesn't really matter what these are. This is just a stop, and that's how we're going to send these in. So in order to do that, let's just turn it on now and try it and see. We'll just push the pins in by hand. Okay, so we've got nothing. The enable lines are jumpered to high right now. So I'm just going to grab 2 of these other lines, and if I bring 1 to 5 volts and 1 to ground, high, low. Let me move this out of the way so we can see it. High, low, then our motor goes. And if we switch these around to low, high, it goes the other direction. So one way, the other way. So good. And right now, because this is high, the enable line is high, this is a hard stop position. So this is drawing current right now. So I'm going to turn off the power supply rather than heat things up. And I can do the same thing with the other side. Okay, so that's not bad. So this is just a bigger picture of what one of these looks like. Like I said, the 2 motors, your power, and then your pins. And you just can get these little tiny wires with it to do that. So now let's hook up an Arduino. I'm going to explain that part afterwards. Let's hook up an Arduino to this and see if we can make the Arduino control these lines instead. So I found this little program on the internet. I'll try and find the link. I'll put the link to the author in the video notes. It's a great little utility for getting going with this motor controller. It basically just controls the 2 motors, and it also takes input from the serial port to change direction and start and stop your motor. It doesn't control speed, but I'll show you how that works in a second. So let's just do a quick little walkthrough of this program. Here it is up here, actually. Reichenstein, the Jamerson.com, if you want to grab this. I think I got it off an Instructable. So this will probably be the basis for the motor controller that we'll ultimately be using for the robot. I'll refactor it and sort of turn it, clean up the code a little bit, make it a little bit more generic. But we use, for each motor, we're going to require 3 pins off the Arduino. We need 1 pin to control the pulse width modulation. In this case, it's pin 9. And we need 2 pins to control the direction, like I mentioned earlier. One has to be high, one has to be low for one direction, and one has to be low, or the opposite, for the other direction. And then for motor 2, we need a separate PWM pin, and then 2 more direction pins as well. We set up the serial port, which is the default for 9600 baud, and we set all of our pins to be output pins. And then we get into the loop. So the first thing it does is it grabs, I think we lost some formatting here, but let's just do that to make it seem a little bit better. We'll figure out the proper formatting later. Oh yeah, there's a bunch of formatting here. Well, let's just fix that now before it drives me crazy. Our, of course, loop is our main loop for our Arduino. This is the one that's just going to get called over and over again. And what happens is we grab a byte from the serial port, and this is not used. And then we get into a switch statement. So depending on what I typed in, it will control the motors different ways. So if I type in a 1, it'll move motor 1 forward. If I type in a 2, it'll stop motor 1. And notice that this is the free spin mode. He's got a comment in here that this is free spin because it sets the pulse width modulation to 0, which drops it low, and then it happens to set 2 of these to low and high. Doesn't really matter what they are when this is low, but it's also the low current draw because it's the motor is not enabled. If we wanted to do a fast stop, we could add another key to this and say, you know, key 8 or something was for fast stop, in which case we would leave the pin high, and then we would set these 2 direction pins to be equal, both low or both high. And then 3 is to do a reverse. So if you look at the keyboard, you've got 1, 2, and 3. 1 is one direction, 2 is stop, 3 is the other direction. Kind of handy. And the exact same thing here for motor 2. 4, 5, and 6 will be left, stop, and other direction. If I type in any other key or enter any other value, it just sets all the values to low. And that's just going to do a dead stop on everything. So it's like an emergency thing. So let's just run this. Make sure we've got our sketch over. It's transferring. And so now it's running, so we'll just bring up our serial monitor here. I'm not sure if this is going to get captured. And if I type a 1, now one thing you'll notice here is I've got no line endings. So when I send something, it's not going to send a carriage return or anything. I just want to send the byte. So if I send a 1, now we got the message that came back from the Arduino that said motor 1 forward. If I press 2, stop, and reverse. And then motor 2 forward, stop, and reverse. And let's look back at the code for that. You'll see that that's where those messages are coming from. The Arduino is sending them back across their serial port, and then a blank line in between for motor 1 forward, motor 1 stop, etc. So I made some changes to the speed control program. The author had a speed variable defined, and it was just set to 0, I think, previously. And it wasn't used anywhere in the code, but I think I know where he was going with it. I added 3 more keys here, in addition to 1, 2, 3 for the left motor, 4, 5, 6 for the right motor. I've added 7, 8, 9, which will just set the speed to 3 different levels, sort of low, medium, high-ish, and then set both motor speeds to that. and not set the pins. We could get a little fancier with that, but this is just so I can see different speeds on the oscilloscope. If it's only going at 100% at 255, that's a 100% duty cycle, then all I'm going to see is just a flat line on the oscilloscope, and I actually want to see the square wave and see it changing, so I just added this to it. So let's have a look on the oscilloscope and see how it looks. So let's have a look at this on the oscilloscope. We're running our sketch here. I've set the speed to 1, and we can see on the oscilloscope here we're getting these are 2-volt divisions, so we're getting our full 5 volts. This is a 100% duty cycle, and there's not a whole lot to see. It's very fast. If we start to drop the speed down a little bit though, if I use this new 7 function, we'll drop the speed down to 64, and we can see on the oscilloscope that we get a much more pronounced pulse. And if we notice here, the frequency is 490.2 hertz, which is exactly what we'd expect. 31,372 divided by the normal prescaler is 64, which is 490.2, which is what we're seeing here. So that's good. That means that based on that timer chip and the default prescaler, we're seeing the right values here. Let's bring up our speed a little bit. Medium speed, we see the pulse change. Go to a little bit higher speed, it changes again. So that's how we're going to start changing our speed. And again, remember, we're going full power for shorter durations of time, and that's how we're going to do speed control. My Arduino wired up to my logic indicators over here. As we mentioned in the sketch, motor 1 direction is off pins 2 and 3, and motor 2 is off pins 4 and 5. And then our pulse width comes off of 9 and 10 over here. These are where our PWM timers are. So I've just got these brought over. So this is motor A and motor B over here. And when we first start the program, everything is down into a low condition. And if I set motor A to go clockwise with the console, you can see we get a low and a high. You can do the same thing with, so 1, that's one direction motor A, that's stop, and that's the other direction. And if you noticed, when I went to stop, the voltage on the oscilloscope dropped down to 0. So if I stop the motor, it's 0. If I start it, it goes up to 100% duty cycle. So one direction, the other direction. And then the other motor, left, stop, right. And then if I drop the speed down, we'll still see our pulse width change, but our directions don't change. So 1, 2. Good. So we're getting everything the way we should. So now let's just take this and hook it up to our motor controller, and hopefully we can make the motors turn with the Arduino. So everything is wired up here now, and one thing I should mention is I had to switch over to a battery supply because I was using the 5 volts off my prototyping board, and then it was also using the 5 volts off the computer, which were different ground levels, and even tying the grounds together didn't help. So now I've just got an independent source here for my power, keeps the grounds consistent, and everything works okay. Also, one nice feature about using that console is because it's 1 byte at a time, I don't have to type in 1 enter and then 4 enter just to move each motor. I can do 1 4 enter and they go across as 2 bytes. So if I want to start the motors here, I can do 1 4 and both start. And if I do 3, 6, they'll change directions. And 2, 5 should stop both. If I start them up again, 1, 4, and then I drop the speed down with a 7. That's my slow speed. And then a little faster. And a little faster. And a stop. Yay! So that works. So that's great. This ground side of it was quite confusing, actually. It took me a while to figure that out. But we're going here now, so that's great. We can control our motors. So the next step, I think, is to make this a little bit pretty. I need to mount this properly. I need to mount this properly, clean up some of the wires, get the Arduino on here, put another motor controller back here for the back 2 motors. And next time we'll talk about pin allotments in here and how we're going to deal with that. There's only so many pins on here we can use, and we've got 6 pins used up for every driver. So there's some gotchas in there. So we'll deal with that next time. Stay tuned.